Right. Right. Got 30 seconds. Oh, not enough time to put the copy on. Yes, just enough time. And here we go. Oops, no, 22. Alright, monkey map. The monkeys take you on a surprisingly easy trail through the jungle. They're even going in roughly the right direction according to your handheld device's grove positioning system. As you walk, the monkeys explain that the grove is protected by a force field. To pass through the force field, you have to enter a password. Doing so involves tracing a specific path on a strangely shaped board. Right, the first half of the monkey's notes is a map of the board. Open tiles and solid tiles, okay. Alternating numbers and letters. A number indicates the number of tiles to move in a direction you're facing. If you run into a wall, you stop moving forward and continue with the next instruction. The letter indicates whether to turn clockwise or counterclockwise, okay. So path like blah, 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 blah. Yeah, makes sense. Begin in the leftmost open tile, the top row of tiles, facing to the right. You wrap around to the other side of the board. Interesting. Okay, I think I can do this. Hello, dear Jay. This one, we're just following a maze. Bloody hell. Okay, fine. It sure is. It's consistent, so I quite like this input. All right, so there we go. $22. So I would say we. Oh, it's one line at the end. Okay. So Okay. We want to make a grid. How... Interesting. Okay, so it's 151 characters, so that's basically the width of the map. So... we can say... for... Okay, and so the height, might as well just fix the width and height to begin with. It's 200, okay. Okay. So it was fun. I worked a 9-hour day and then had to come home and shovel about 8 inches of snow off my driveway. Oh, goodness. Is it replenishing the snow every day? Also, I need that coffee. Alright. I can do some thinking while I grab my coffee. With the last snow for a week or so. Okay. Right, so we want if not lined up. If whatever, let's just say if it begins with 2, if ought 2 in line 1 orders equals line dot strip break. Alright, so otherwise we want to just check the line and say we don't want to strip it. But we do want to take off the strip. Okay, cars. We want to change cars. So for okay. All right. Line dot strip. Cars equals n. Let's just say this grid dot append list of that. Let's take this out. Okay, we'll populate the grid like that. For row in grid, print row, print orders. Let's see what we've got here. Strip takes no keyword arguments. What? It does though. Should I be saying this? How do I use cars there? Alright, let's just make sure we're getting good. Okay, do line. -1. Let's just check we're getting it correct. So it should be 4 dots at the end. Yeah, okay. Alright, that's pausing. Alright, so position. Equals grid 0 dot find dot index dot. That's where we start. J equals 0. leftmost open tile of the top row of tiles. You are facing to the right. Okay. Direction equals, should we say, as a vector, so 1, 0. That means we're moving 1 horizontally, 0 vertically. So position equals yeah, that's fine. All right. So okay, we need to, these orders, we need to break them up into, how do we even do that? So the orders are of the form number, R or L, and number. So you go forward 10. Oh no, it's just number, RL, number, RL, number, RL, and so on. So how, what? Okay. While true, well, let's just say how do we finish this orders? It's a number, okay. Hello, Ku. How bad is today's? Not bad. It's parsing is well, parsing is fine as well. It's basically following a set of movements through a maze. So there's nothing really that could go wrong. The maze looks like this. It's not, and they've given you exactly the moves to take. But it's like turn clockwise, go forward, turn anti-clockwise, go forward, and so on. But it wraps around. So it's like, what's the term? Klein bottle. We're moving on a Klein bottle. If you go left, you end up on the right, and so on. And the hash keys are the walls. Okay, so I just need to finally parse these orders. Is there a way to do this easily in Python? I don't know. Let's just say while I is less than length of orders. Oops. It equals, so we want orders dot find Oh, it's got to be a better way to do this. I'll just do it completely by in indices. So let's say not find. Okay, if the character we're looking at is a digit, while orders okay, so now we've moved it to the next non-digit, and we say num equals int of orders. Hang on. There's got to be a better way of doing this. It equals like splitting on. Yeah, but splitting doesn't preserve the separators. It equals it. Damn it. Hang on. Okay, from it up to new it. LF orders. All right. Else. Direction equals turn equals orders it. Okay, now we just need to deal with these. So we've got move forward num. And here, turn. Okay, so far so good. So this is just literally just keep making one step forward. Okay, for new. Okay, so but the thing is, we have to handle the wraparound. Now this is the confusing bit. Okay. Next tile is position Alright, so it's going to be position 0 plus direction 0, position 1 plus direction 1. We need to know the width and the height of the grid. So we need to do modulus. So that gets us the next tile with the wraparound. Oh. Well, that should be height. Okay. While next tile, while grid, next tile 0, oh, next tile, yeah, 0, next tile 1 is an empty space. That just keep doing that. So now we're on a non-empty space. So it's either a dot, which means we can move to it, position equals next tile. Break out of the... No, don't break. Else, if it's a hash, that means we can't go there. So we just break. We can't do any more movements. We just keep walking into the wall. That should be it. And then for turning, what's the easiest way to do this? Just say if turn is L, direction equals, so we need to replace direction with, can we just, how about this? Let's do, so if we're going to 1, 0, we want to replace it with 0, -1. We're at 0, -1. We want to replace it with -1, 0. We're at, we could do this with matrices as well, I suppose. -1, 0. You go to 0, 1. And 0, 1. You go to 1, 0. Like that. Just extract it like that. And then the other way is, I guess, we do 1, 1, go -1, -1 to -1, -1 to 1. Alright. Alright, that should do stuff. It didn't actually terminate. There's various while loops here, so I need to fix that. It's probably stuck in one of them. So the actual answer we want is final row, column, and facing as your final position. Starting from 1 indexed. Row 1, column 1, it refers to the empty space with no tile on it. Oh, that's good, okay. Zero for right. Okay, final password is the sum of 1000 times the row. Alright, so row equals position 0 plus 1. Column equals position 1 plus 1. And then facing equals, it's basically this, isn't it? But so if we're facing to the right, it's 0. If we're facing up, it's 3. Facing left, it's 2, then 1. And then finally we want 1000 row Alright, this doesn't terminate, does it? No. Okay. So what's next? We don't need to print this anymore. We do need... hang on. That shouldn't be there. Okay, so we print, move forward, num, just to make sure we're actually doing these. Move forward 25, okay. Seems to be stuck there. IT. Also, while new t is less than length borders and that, because otherwise it's just going to crash. So we are able to extract the none. Now we're stuck in this one. So next tile is position 0 plus direction 0. Percent width, okay. All right, starting at 50, 0. That's wrong. Should be starting at I equals 0. How did I manage that? Huh. Okay. Zero 50, 1 0. Well, the direction should be 0 1. Because I'm confusing X and Y's and I's and J's. Stick with I's and J's. Alright, so those two are correct. But later on I did this. So this 1 0 is actually down. If we turn left, we end up to the right, which should be 0 1. We go from 0 1 to the right up, which will be -1, -1 0 to 0 -1. It's left and left. We turn back down. Okay. And then the other way we go, if we're facing down, we turn right, go to -1. From -1 we go to up, which is -1. Go from up to right. Go from right. No. Yep, that's right. And then finally, right should be 0. So where is right? That should be 0 1 goes to 0. Hang on, let me do this from the description. Facing a 0 for right, 1 for down. Down is +1 0. Left is 0 -1, so that gives us 2. And up -1 is 3. Okay, now those should be correct. And then this one here, position 0 plus direction 0, should be done by height, because that is actually... Okay, turn those around. Still stuck. Alright, but those are somewhat correct now. Alright, so we start at 050. Is that right? So we start 1 here. Yeah, that's 50. Okay. Facing to the right. Move forward 25. So position equals next tile. Print position. 62. We should be breaking out of this for loop. We're actually stuck in the... Oh, damn it. I didn't move the iterator. That's why I hate these iterator methods then. They're dangerous. Index out of range. Move forward 42. So we're at 062. We've turned left. Move forward 42. So at 062, we've turned left, so we should be subtracting 1. So we get to minus 162. Minus 1 should bring us back that wrap around. Why, what's happened here? $199.62. Oh, damn it. We need empty spaces. Oh, okay. That's not helpful. They didn't put the spaces in the graph. Okay, fine. For row in grid, if length row is less than width, row plus equal, we want space times width minus length row, is that correct? Hang on, I don't know. Oh, no, we can't do it like that. No, we gotta do... whatever. For... okay, do it like that. Still stuck. Oh, no crash this time, so it's now stuck in an infinite loop. We get as far as... so we're at 063. 063 should be this one, the hash. Next tile, the next tile is a hash. So if it's a dot, we move to that tile. So we're now at 63. We're looking up. We're doing move forward 42. Let's see what's wrong here. So we move to 19962, and we're looking up now. 19962. So we should be in this empty space here. So what's going on here? We have to update next tile. Damn it. So many mistakes. Not position. Otherwise we're just getting the same tile over and over again. Alright. 97356. Let's just try that. Correct. Took me longer than I'd hoped. I mean, it's clear enough how to do it. It's just weird, piddly, line-bottly map to deal with. And the input, it'd be nice if they had put some placeholder characters to represent the empty spaces, because the empty spaces are actually trimmed off the ends, which means you have to put the empty spaces back in. You don't technically know the length of the map. I'm going off by the first row, which is fine, I guess. Can't you just do line.strip? No, because the empty spaces are not there in the first place. All the empty space... hang on. Yeah. Some of these go up to like here, and some of them go up to like here. So I had to add in the empty spaces to it to make up for it. So I had to go off the max width, basically. All right. Now what? As you reach the force field, you think you hear some elves in the distance. Perhaps they've already arrived? You approach this strange input device, but it isn't quite what the monkeys drew in their notes. You're met with a large cube. What? Hang on. A large cube. Each of its 6 faces is a square 50 by 50 tiles, right? The monkey's map does have 6 50 by 50 regions on it. If you were to carefully fold the map, you should be able to shape it into a cube. I don't like where this is going. Oh, so we're moving on a cube instead of a wine bottle. So if you're at A and you move to the right, you would arrive at B facing down. If you're at C, you would arrive at D and the facing would change. Oh no. I mean, this is not okay. I can just handle all this with a get neighbor function. I just don't know what all the changes are in the first place. I have to visualize wrapping this as a cube. Walls still block your path, even if they're on a different face of the cube. Mm-hmm. Damn it. Okay. Okay. Oh dear. The cube is 50 by 50. Okay, so now that I look at this, we can probably... Uh-huh. I don't see how this folds into a cube. So 50 by 50, so that's... So that's 50. That's 50. I feel like there's way too many faces here. What am I supposed to do with this? This doesn't look anything like the example as well. Okay, so no, maybe. All right, I think I see it. So that is all right. So from here down to here is one face, and on the right that's another face, and then we've got one more. 1, 2, 3, 4, 5, 6. Okay, fine, I see it now. They're just very elongated because of the way the line breaking works. Right, so I need to draw something. So what we've actually got is 1, 2, 3, 4, 5, 6. Okay. And that is not even the same shape as the example, so this won't even work on the example. All right, the good thing is that, well, okay, so I can't even really explain what I'm thinking without. I need to be able to sketch a cube on the IDE or something. Well, I can indicate here. So this edge here. No. This edge here lines up with this edge here. Oh man. First step is just to make some sort of method which figures out all this logic. So first we need to maybe the clean thing to do right now is first to make a method which handles wrapping. So wrap 1, that's climb bottle. Have I got this right? Is it climb bottle or is it? Oh, so you. No, it's Taurus. Wait. Yeah, it's Taurus. Climb bottle would be if you swapped one of them directional and then wrapped them. So yeah, not climb bottle, it's Taurus. So given a position and a direction, man. This should actually be get next. So basically it's this logic here. So we say next tile equals that. Stop printing stuff. Return position. So we say hang on. Okay, return next tile. Otherwise, return the original position. And now we just say here, we just say position equals get next one position. Does this still give us the same answer? Nine, 7, 3, 5, 6. Nice. Okay. Okay, so that's basically, we just need to write a new method here. That's everything. This logic is fine. Oh, this is horrible. Alright, let me put on a new copy, I think. Just out of interest, let's have a look at my rank for part 1. We want personal stats. About 1,100, okay. It's gonna be so hard to debug this if I make a mistake, because the test example they gave is a completely different cube. I don't see how it can even really relate. Like, you can't, how do you use logic to work out how a given cube should actually, how a given template should actually wrap up to a cube? It can be done, but yeah, really? They couldn't have given us a similar shaped template in the example? Can we make it similar shaped? So, have a look at theirs. No, it can't even be rotated or flipped. It's structurally different. In ours, we have a bridge of 3 cubes connecting 2 parts. That's ridiculous. All right then. Get new coffee then. This is fun. Well, we're getting into... Okay, so from what I understand, the final 2 days, 24 and 25, traditionally are easy problems, because they don't really want to give people hard problems on the final 2 days. So the last hard problem we could have would be tomorrow, 23. 24 and 25 usually are nice problems. Traditionally. But who knows? Something to eat. Alright, if it takes me longer than an hour or so, well, I can sort of see what to do. It's just gonna be a lot of manual stitching of the cube. Got some pickled quail eggs to sustain myself. So I think the first step is to create a list of what I'll refer to as stitches, which is we have to actually paste the vector of one of the edges and the vector of the edge that it matches. Um, but still need to think about this. Oh man, this is ridiculous. Okay, so... I'm actually gonna have to make a cube out of real paper, just to understand how this... Okay, so... Let's just start with one of the edges. So we want... Some of the edges, it's clear enough to see where they match up. So if we just make a hash map of positions and directions, so if you happen to be in this position facing this direction, then if you take one step forward, you end up here. We just do that for every edge. So let's say wrap map equals that hash map. So it not only it spits out a position and a direction, because your direction actually changes. You could be going right, and then when you come back onto the cube, you could be going up, something like that. So how many edges have we got altogether? One, two, well, we have to divide by 2 eventually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7 pairs. Okay, do this. Yeah, I need some coordinates. So that's... Here we go. All right. So edge 1. So let's start with the left edge here. So where does that end up? Alright, well, it looks like it ends up against this left edge here. In reversed order? Hang on. No. No. It matches up with this horizontal edge here. It's amazing how complicated a cube makes things, yeah. Like, it'd be so much easier to traverse a Klein bottle, the impossible shape, than a cube. It actually would. Well, why do I say impossible shape? It is a possible shape. Well, no, it can't be embedded in 3D space, so it is an impossible shape. But you can still have a map based on it. Right, so okay, I was wrong the first two times. It lines up with this left edge here. All right, let me think that over. Yeah, I think. Yes, it does. Okay, and it is. So this corner, this piece here, will match up with this corner here. All right. So the first edge is am I disconnected? Wonderful. Alright, am I back? I'm gonna just unplug this stupid Ethernet. I thought Ethernet would be more reliable than Wi-Fi. I think the actual cable is cheap trash, so let me just... I'll just leave it for now. I won't change anything. Alright, so... Okay, so this edge, we can describe it like this. We can say 50... No. So the row is 0 plus k, and the column is 50 for k in range 50. That describes that edge up there starting from the top. Does it? Yeah. And it's not edges we're doing here, it's, let's say, wrap 1. E2 equals, so starting from the bottom point and going upwards. So it's 150, 149 minus k zero for k in range 50. No. Wait, does that even make sense? 150. Why am I starting from 149? 150. But no. Yeah, no, it is 149. Okay, fine. Those two match up. Okay. Let's, so for let's use K just to match the letters. It's clearer then. So wrap map of E1K with the direction, which is 0 minus 1, equals E2K and the new direction. So the direction was left. And the new direction is right? Well, yeah, it has to be. We're going into it. Okay, fine. And then we have to do the opposite way around as well. E2K, if we're going right, we end up going, if we're going left, hang on, E2K, going left from here, we end up going right here. Alright, that's one edge done out of 7. but it will get faster. Copy that. We now have to... Now what? So that's one edge off the list. So I move on to... So that's the first edge. Let's move on to this edge then. So that pretty clearly maps to this edge here. So first one is E1. So it will be 50 plus K, 50. That one's straightforward enough. And the next one will be 4, so it'll be $100. Row 100. Column 49 minus K. I have to think this over like 100 times in my head. It's crazy. I would be interested to see what shortcuts people took. See what you have to manually. I don't think there's anything in Python that could. Unless someone's made a library that can wrap up cubes and create a cube wrapping map, which I'm sure someone probably has done. So that's, yep, okay, so we wrap map E1, we're going left, that maps to E2 going down, so we want 1, 0, and the other way, if we're going up, so -1, 0, that maps to E1 going right, 0, 1. Okay, it's the second wrap. All right, wrap 3. What next? Let's just go around anti-clockwise because that's sort of what we've ended up doing. So this one here, where does that go? Oh no, this is the tricky one. Okay, so we've already established that the one immediately above it maps to the very top edge that we've dealt with. That means that one has to map to this top edge here because it's continuous around the boundary. It gets easier now because we can follow the boundary. So this left edge here maps to this top edge here. Okay. So we got E1, it's row 0, 50 plus K, and then E2 is 150 plus A 0. And then if we go up from E1, we end up going right in E2, and if we go left in E2, we come down in E1. Alright, almost halfway then. So I suppose we just continue around the boundary, because that's... Hang on. It's so confusing. Alright, let's just go for something which is pretty clear, because I don't think the others are clear. Alright, let's go for this edge with that edge. That's clear enough. Like, if we do all the clear ones, the ones that are left, it's just easier to work out what maps to what after that. Map 4. I should number these on my diagram as well, because I'm going to forget. There was 1, and we did 2, and then 3, 1, 2, 3, noding 4. Alright, so what we got? So this edge here. It is 100. So the row is 50 fixed. Actually, it's 49. And it's 100 plus K. Okay, in range 50, and then the next one is the row is 50 plus K. And the column is 99. All right. And then we map. So if we're going down, in the first one, we end up going left. And if we go right from the second one, we end up going up. Then none of this works for the test example they've given, because I've tuned this to size 50 as well. All right, that's wrap 4. Let's do another easy one, which is this one here, going with this edge here. Wrap 5. All right, let's see. So it's similar to before, but we start from, so it's going to be row 149, starting from 50, and E2 will be row 150 plus K, column 49, and it's exactly the same directions. We can keep that logic. All right. Finally, 2 more. Wrap 6, and I think it's clear where these ones go. So wrap 6 will be, let's go for this right edge here, and that maps to this right edge here. So we close this one with this one, and we end up stitching this one to this one. All right, so E1 will be row 0 plus K, I guess. And column 149. E2 will be, okay, how does so we have to do this one backwards because they stitched, because you just have to do that. So we go from row 149 minus K column 99. And the directions, I think, again, it's... No, it's not the same as before. wrap 1. If we go right, we end up going left. And if we go left from, no, if we go right from the other one, we end up going left to the first one. Yeah, right, left. Just like the first wrap. Right. And finally, wrap 7. So that is... And this edge up here tied to that edge all the way down there. So the first one is, so it's row 0. And it's 100 plus K. And the second one, okay, so the orientation, there. The orientation matches. It's almost like you're making it to a cylinder. But, okay, so E2 will be column, so row 199, and it'll be just 0 plus K. And then if we go, so from the top, if we go up off the board, we end up going up into the new one. And if we go down, we end up going down. All right, that's all the wraps. Now the logic, we need to say if we're at position and a direction, I mean, the logic here now is simpler. We say we first, wait, hang on, no, don't change get next 1. Oh yeah, no, this is get next 2, okay. Alright, so get next 2, we've got a position and we've got a direction. If position direction in wrap map return wrap map position direction, so that immediately tells us the next where we end up. Otherwise, it's safe to just take one step. So, new next tile. Wait. We still have to check for walls. So, next tile equals that. else next tile equals basically what we did before. Next tile equals position. Okay, we don't need to do percent with height. Not that it matters, because we're not actually going to roll off the end. While we see an empty space... Oh. Well, we kind of need to repeat this, don't we? Well, this is bad, but this is a badly written... Okay, fine. Whatever. This is kind of one of those rare scenarios where you would like to use a do-while loop or something like that. While... Okay. And now we just copy and paste this, say else next tile equals that. And keep next direction the same. That I don't. Okay, I don't like that, but whatever. While we're on an empty space, do that, and now we have finally arrived at a tile. If it's dot, we return next tile, next direction. Otherwise, we return the original position and the original direction. What a mess. Position 0, direction 0. What's happened here? Can only concatenate tuple, not int to tuple. Position and direction have become tuples or become something, become an int. Or no, what's happened? Alright, so in the wrap map we take a tuple of two tuples and we map it to a tuple of two tuples. Yeah. So, unless we were to violate that at some point. So that pulls out a tuple from the wrap map, so we end up with a tuple of two tuples, so that should unpack them correctly. Next tile equals I'm not doing this one correctly, so there we go. Position was becoming a multi-layered tuple. Bad. This is probably the most untrusting I've ever been in an answer. 17540. There's no way. And we had no errors. That just makes me more suspicious. 17540. No, it's too low. Now what? God. So turning is fine. Let's go back and print all this stuff. Okay. Let's try. Next tile, next direction is that. If it's an empty space, hang on. There should be. We should never hit an empty space now. The whole point of this stitching is that we stitch it perfectly, so it always end up back on the map. That being said, this shouldn't execute anyway, but all this logic we can take out now. The wrapping is supposed to never put us on an empty space. That's good, because there's less to debug there. Alright. Same answer. Good. Alright, so let's check get next is correct. Because this is pretty easy logic now. So if position and direction is in wrap map, then we know where the next place is. It is whatever wrap map says. Otherwise, next tile will be position 0 plus direction 0. Position 1 plus direction 1. And next direction equals the old direction. Fine. If grid of the next tile is a dot. Then we return next tile, next direction. Otherwise, we return the original position. I'm pretty happy with that. Get next to. Pick this out. So it's really up to the wrap map. I might have to check all those again. Let's check this logic as well. So this should all be the same as before. Position direction equals get next to position direction. Yes. And okay, let's just print the intermediate places we're going. So what does it look like? So here's a jump, 1992 to 49,140. It looks pretty sensible, actually. It's what you'd expect. In terms of wrapping around the cube. We just have to check our wrapping is correct. Okay. Alright, let's start with wrap 2 because that's actually clearer off on my diagram. Okay, wrap 2. We got 50 plus K. Column 50, yes. And that maps to backwards, starting from, so it'd be row 100, correct? Starting from column 49, moving backwards, correct. I am happy with that. The directions. So if we go left, we end up going down. If we go up, we end up going right. Okay, I'm happy with wrap 2. And then when wrap 2 is satisfied, wrap 1 is what's left. So, and it's basically backwards. So wrap 1, we start from 0 plus K, column 50, yes. And wrap 2, it's column 0, go from 149, backwards, yeah. And then if we go left, we end up going right. If we go left from the other one, we end up going right, yeah. Right. Okay, let's move on to wrap 3 then. So that one is okay, so the very top edge, top left edge. So we start from it's going to be row 0. We go 50 onwards. Yeah. And that maps to E2. Is that the correct way around though? Okay, so it's column 0 and it's 150 onwards. That looks right, yeah. Alright, I'm happy with wrap 3. Wait, directions. So we go up. We end up going right. We go left. We end up going down. Correct. Alright, wrap 4. Right, this one should have been an easy one. We start with, so it's going to be row 49. Yep. We go from 100 onwards. Yep. And that maps to row 99, column 99, row from 50 onwards. Yeah. If we go down, from there we end up going left. And if we go right, we end up going up. Yeah. Wrap 5. So we should, the first one should be row 149. Yeah. Column 50 onwards. Yeah. And that should map to column 49, row 150 onwards. Yeah. If we go down from the first one, we end up going left. And if we go right, we end up going up. It's all looking fine so far. Right, 6. Right. So this one is a reversed one. So we say, so the first edge will be, hello DJ, I got a wrong answer for my first attempt. I'm now checking all the cube sides. So far they're looking fine. I'm on the last 2, so wrap 6. So we start from, so it's column 149. Yes. And the row goes from 0 onwards. Yes. And then that maps to the reversed edge. Starting from, so it's column 99. And we go 149 backwards. Yeah. Now, if we go right, we end up going left. And if we go right from the other edge, we end up going left. Okay, and then the final wrap, 7. We've got, so it's gonna be row 0, column from 100 onwards, and the other one is row 199, column from 0 onwards. If we go up, we end up going up. If we go down, we end up going down. The only thing that I'm not 100% sure is E2 reversed or not when I fold that one up. No, it's not. They're the same. Okay. I'm pretty sure I've checked the cube completely by eye. So, oh, I have no idea how on earth am I going to debug this? So my answer for the first one was about 97,000. For this one I gave about 17,000 and that was wrong. I suppose we just have to check the first view and hope that the error is present pretty early on. We're starting at 050, facing to the right. So there. Starting there. Move forward 25. So we should end up kind of against that hash there. Hang on. So 150, move forward 25, we end up at 062, facing to the right. Is that right? the hash is at 65. So we should be on 64, but -1. So we should be on 63, surely, not 62. It doesn't seem right. Are we off by 1 here? So we're standing at that one, 50. Yeah, I think this is actually... Oh, no. Oh, this is right. Yeah, we should be there at 62. Why did I think it was... I had my cursor in the wrong place. Yeah, so yeah, we end up there at 62 and facing to the right. Okay, that's correct. Turn left. Now we are at 62 and we're looking upwards, okay? Now it says move forward 42. So we go off the top edge and that should take us to this bottom left edge down here. So we end up at move forward 42. So we end up 162.0. Hang on. No, something isn't right here. Damn it. Okay, yeah, something's wrong here. We did jump to the correct cube face, but we shouldn't be on column 0. We should have moved into it a bit. Because we do this 42 times. Position direction equals get next position direction. Is it possible that... So it's wrap 3 that we're on here. So if we are of the form 0, 50 plus k, which we are, and we are facing upwards, which we are, then we should teleport to the equivalent position in E2, 162. Yes. 0. But we then end up facing to the right, and we then should move another 41 steps. Interesting. Position, direction, and wrap map. At this point, it shouldn't Oh, but wait, is there a... There might be a wall there. 162.0. 161. No. There isn't a wall there, so there's definitely a bug here. So we end up there. So for some reason... Position direction equals get next to position direction. Okay, we're gonna have to print some more stuff here. Alright. Move forward 25, we're moving. Nice. Okay, and then we get stuck there. Fine. Turn left. Now turning there. Move forward 42. We take one step and we go over there, and now we're not moving at all. What's up with that? 162.001. 162. So that should be, so lines start from 1. So 162. Should be, oh no, this is correct. Damn it. I was looking at the wrong line number again. Alright, so this is correct. We're stuck at a wall. Okay. Turn left. So now we should be looking upwards. Move forward 39. So we should end up here. Correct. Is it? Hang on. No. Oh, no, it's doing it step by step. Okay, yeah, so 159. Yep, that's correct. Turn left. So now we should be looking to the left. Move forward 15. So now we end up back at the top edge. That one's easy to calculate, you just subtract 100. And we should be going down. And we end up there. Somewhere there. 60. And then we keep going until we end up at 659. So that's line 7. Yeah, we hit that thing. Everything looks fine so far. Turn right. Move forward 17, so we should just end up a little bit forward. Turn right. move forward 38, so now we should end up just against this thing. To the left. I don't know how to resolve this. It looks really secure. 1750. 17540. Let's go back to using map. But let's go back to using get next one. Nine 97356. Was that the correct answer still? 97356. Yes. Damn it. So the only thing that could really be wrong is the wrapping, really. Oh dear. Should I actually go ahead and make this tube then? think I have to. How long have we been? 2.5 hours. Not too bad. I mean, it looks reliable for the first few moves, so I reckon at some point I'm just ending up in a wrong place because of the wrapping. I don't know. I can either I make a cube, or I think the better thing to do first is to just mark my movement on the map grid itself so I can print it and see what it looks like. There's no way I can use the test example to test my code. It's a completely different map. Yeah, the only thing that could be wrong here, it's gotta be the way I'm moving around on the cube. I'll have to just go through it again. Alright. Need a 5-minute break, first of all. Alright, let's try printing an actual map of the where we go. So make a copy. We say every time we update, you say okay, stop printing these for now. grid, copy, position 0, position 1, equals, and let's just translate these to, so if it's going down, we want a, I don't know, V, I guess. If it's going left, we want, what? Left bracket. We're going up. We want that. Going right. That. Similarly, all right, and then for row in grid, copy, print dot join row. Let's try that. Bloody hell. My god, there's a lot of movement here. It can't be right. Is that really how many times we move about? It's crazy. And that is for the second one. For the first one, nine, 7, 3, 5, 6. Alright, what am I supposed to do with this? How many orders are there? 1,000. I wouldn't expect it to cover that many tiles, but I guess so. So for 2, we start there, we go here. Because we're crossing parts, so it's a bit confusing now. So we go up, we end up, let's see. This is not going to help. But so far, it looks as we'd expect it to look. Nothing weird. We are going right up to the edges all the time. That's good. Should be. I think we just have to go back to debugging this wrapping method. Alright. I actually make the cube then. I need... Don't really have the greatest tools here. So scissors is not for this purpose, alright. So let's see, we've got I don't know how to do this. Let's do that cube. That cube. That cube. These are squares, not cubes. Square. That square. That square. Alright, let's try this. Finally happened. Having to do origami to solve the programming problem. Alright, that's what I got so far. I'm gonna have to... Right, I have to put numbers on according to how I've actually arranged this in the thing. So we've got 1. Okay, then we got 4, 4, 5, 5, 6, 6, and then the final one, 7, 7. If this actually... I mean, I think I was correct in my head. So that's with numbers. Don't even know, is that showing up? Yeah, no, whatever. have to fold it outwards so that the numbers are still visible. There we go. A little cube. Let's take the numbers all match up. The numbers do match up. But do the orientations match up? How do I even figure that out? Yeah, okay, so 1, 2, and 3 I think are fine. Okay, 1 is reversed. Hang on. Something's wrong here. No, that's fine. It is reversed. Yeah, okay. Why is 2... No. Okay, let's check this again. 1, we're going downwards. E1 goes downwards. And the other one goes upwards, because they're reversed. Okay. 2. Something looks a bit weird about 2. The first one goes downwards. Oh. I think this might be the mistake. Okay, I reversed E2. It shouldn't be reversed. It should simply be going from 0 plus k, surely. Why did I reverse that? Yeah, 2 matches up, same orientation, nothing needs reversing. 1 needs reversing, 2 doesn't. So 2 should be 50 plus k, 50, yep. And it should be 100 and 0 plus k. Yeah, that was a mistake. There could be others, but okay, I've checked 1, 2, and 3. I think 1, 2, 3. Correct, and 3 is 0, 50 plus k, 150 plus k, 0. Alright, let's run this again then. There's a different number. Come on, could that just be it? Oh my god. Solved. With origami. You see the numbers? Just about. Nah, not really. Alright. And that's the finished cube. I mean, the cube... The one I got wrong was actually the easiest one. Which was... this left edge No, sorry, this left edge with this top edge here. I reversed it. There was no reason to reverse it. This point matches to this point matches to this point, and so on. It's not reversed. It's exactly the right orientation already. 1 and 3, 1, which is adjacent to it, is reversed. Damn it. Alright. That would have saved me about an hour. I think my debugging process was reasonable. It's just, I double-checked too, and I still arrived at the same wrong answer. Maybe the problem was I was biased, so I think when I was double-checking my wrapping, I was looking at what I wrote and I said, yeah, that looks right. Yeah, that looks right. That's the wrong way to do that. I should have obscured it from my vision and just said, okay, this line should look like this. And then check that it matches what I wrote. I think I was doing that for like 4 onwards. But I started by just checking. That's a really bad way to do it, because then you just fall into the same trap, because you see your mistake but you don't realize it. So that was bad way to double check it's correct. Wow. Let's have a look then. Have a look at the stats. How quickly do people solve that? Oh, wow. 1 hour 14. That's pretty slow. Took me about 3 hours. Yeah, I don't see that being easy to put together. There is a big jump here. Look, 26 minutes to 39 minutes. And then from then on, everyone's roughly about 39 minutes. So, kudos, Mr. Flip. Have a look at other stuff. Leaderboard. How do I... Oh yeah. Personal stats. Oh wow, my rank actually went up for part 2. People are still stuck on this cube nonsense. I can't believe I actually had to make a real cube. Honestly, I should have done this to begin with. It actually did help me work out the orientations. Alright then. That was crazy. Tomorrow could be a tough one, because I know that 24 and 25 are usually easier. Okay, well, see you tomorrow then.